All right, so let's talk about convergent boundaries. On the convergent boundaries, again, what does that mean? To converge means to come together. So we have two plates that are colliding. They're basically moving toward one another. And we have three types of convergent plate boundaries. If you know anything about math with probability, if you have two types of plates, you have three different ways that they can come together. So we have ocean colliding with an ocean. We have an ocean colliding with a continent. And then we have continents colliding with continents. We're going to look at these in more detail on each one of those. Because one of the things that you guys will be expected to do on your test over this weekend is you'll be expected to describe what happens in each one of those cases. And there are unique landforms that are created due to these collisions. So it's really, really important you guys pay very close attention here and write these down. So the first one, let's say look at ocean to ocean. So basically what happens is you get this thing called subduction, right? And that's something that Tom had already talked about. We have subduction taking place. All right, early on in this course, we had you guys find the mass and the density of the salt in granite, correct? Which one's more dense, the salt or granite? The salt is more dense than the granite. Okay? So think about density. What happens when things are dense in the liquid? What happens to the denser materials? Where do they go? Denser materials fall down first, and then eventually the lighter materials, the less dense, falls on top, right? So when you had two things colliding, the denser crust is the one that gets subducted. So ocean crust is always the crust that gets subducted. It's a very dense crust, that's because of the salt that's free. Okay, so the ocean is always going to be the one that gets subducted. Now when it gets subducted, all that crust, that's a lot of heat and a lot of pressure. So what happens is that the crust starts to melt. But then as it melts, it becomes less dense. So what does it start to do? It starts to rise up. So what we have, this is those landforms you need to be able to identify. We have your subduction zone. You have your trench. So you're always going to get a deep ocean trench with subduction. And then this is the most important piece. On the other crust that's not being subducted, you always will get this rising of magma. And what it creates are these volcano chains called volcanic chains. And this is actually really neat. I want you to think about it. Logical sense. Logic. If I have an ocean colliding with an ocean, that's a whole lot of water, right? So look at the diagram. What do I actually have here? I've got land surrounded by water. What do I have? Volcanic island chains. Give me an example where we have volcanic island chains that are formed or two ocean plates coming together. Okay. Not Hawaii. Hawaii is a unique spot called a hot spot. It's a random place within, this is actually really important for you guys to understand too, hot spots. It's basically a weak spot in the crust where the magma is able to well up. We don't know why they occur where they do, but those are called hot spots. In fact, we can use hot spots to actually track the movement of the plates. And I'll show you that later. Make sure you guys know me to show you that later. So, any other ideas? Well, we might have these. Yeah, a lot of the East Asian has a lot of them. All right, and actually, that's more not from ocean to ocean, but rather ocean to continent. We get a lot of these from ocean to continent. One thing I can think of as an example of this would be the Aleutian Islands. Right here we have the Aleutians, and that's where the Arctic plate and the Pacific plate come together. And you guys can see that deep trench right here in front of the Aleutian Islands. And these are just long chains of volcanic islands that occur, stretching all the way from Alaska all the way over here, almost to Kamchatka in Russia. Which again, I'm not sure if you guys know much about your history, but Attu Island right here was the only piece of the American mainland that wasn't invaded during World War II. And it took us several months to get that territory back. And then we can also see a little bit here down the Japanese islands, all the way through the Philippines and the Marianas Islands. Another example of the Pacific Ocean colliding with another ocean plate. That's ocean. When we have ocean and continent, it's almost the same exact diagram. But what's different now? We no longer have islands. What do we have? What will it look like to you guys? Mountains. So now instead of volcanic island chains, we have volcanic mountain chains. Examples of that, we'll see right here. So as that ocean plate is being subducted, you're getting a melting of the crust that then wells up and creates these volcanoes. Give me some examples where we have these. Where do we have volcanic mountain chains due to an ocean being subducted underneath the continent? I'm amazed at your guys' lack of geography and knowledge.
Is that Hawaii?
No, it's not Hawaii. What? Yeah, keep going. Keep going, we're getting closer. No, we've lost it. What are those mountains called? The whole spine along South America, what are those mountains called? All the way from the tip of Chile, all the way up to Venezuela. What? No. You ever feel like just wasted? You come to work and just, whatever you do is just wasted. How I feel. How about the Andes?
Okay, because we don't do that.
Okay. Andes Mountains, there, that's on the whole spine of South America. And that's a whole chain of mountain island, or not mountain islands, but volcanic mountains is because of the Pacific plate being subducted underneath South America. Going back to the globe. In fact, this set of mountains, specifically these are called Andes in South America, but actually you can see the ridge go all the way up from South America, basically from the South Pole, just about, all the way up to the North Pole, where the Pacific plate is being ground into or under the North American plate and the South American plate. We had these volcanic mountains that stretch up the whole way up the Americas. Right here in the America Northwest of Oregon and Washington, we had two very, very important volcanoes. Mount Hood is one of them. That's in Oregon, outside of Portland. And then Mount St. Helens and Mount Rainier in Washington. So those are some of the volcanic mountains there. Those are called the Cascade Mountains. I like this. You guys. I know at least some of it. We do have some very non-active volcanoes throughout the stretch called the Sierra Nevada in parts of Nevada and California. And some of the Rockies as well are some ancient volcanoes. Okay, so that's some of that taking place there. Now, some of you guys did mention the Alps and the Himalayas, but those are actually not volcanic. They are mountains and they are chains, but they're not volcanic. In fact, those two, the Himalayas and the Alps, are formed when a continent collides with a continent. And basically what you have is in both cases, they are equal density, therefore neither one ducks underneath the other. And what you get is the squeezing of the ocean plate in between them. And it literally gets squeezed to the point where it's no longer there. And then you get these large, very, very large mountains. Examples of those are the Alps and the Himalayas. So that's basically it. So with these, you just get very huge mountain ranges, but they're not volcanic. When we look at things like the Mediterranean Sea, and in a few million years, the Mediterranean Sea will no longer be there. Every day, the African plate is moving closer and closer to the European plate. In fact, you guys know the Straits of Gibraltar, known also as the Pillars of Hercules. And you guys know what I'm talking about or no? Okay. It's like a 10-mile gap between Spain and Morocco. And over time, that gap is going to close. As Africa keeps inching closer and closer to Europe, you're going to have that gap close off, and the Mediterranean Sea will basically dry up and eventually be forced underneath Africa and Europe. In fact, it's already happening, and we'll watch an episode on this one, on the Alps. They talk about the Matterhorn, one of the greatest mountains of the Alps range. The very top of the Matterhorn is actually a piece of the African plate. So a lot of cool stuff if you guys know where to look for it, and you at least want to think about it. And we guys rather think about what, who's the top 10 on the billboards of the day. But just a lot of interesting things to think about. Okay, well, we're almost done here. The last one I'll talk about is a transform boundary.